Alright guys, today I'm just going to be showing you a brief presentation on how a car works, or more importantly, how the engine that's within a car operates and creates the work that really allows us to move these cars. So hopefully it's really interesting. You learn a lot from it. So beginning, we first have to just understand what an engine is. So the most common type of engine used by our cars are the internal combustion engine. And while that sounds like a mouthful, I think we can break it down pretty easily. So if we look at the first word, internal, all of the mechanisms and the operations exist inside of a single system, as opposed to it being spread out across a variety of systems or outside of a single chassis or body, right? And then the second word is combustion. And it's a big word, but it's really simple, right? It just means that something is being burned. In this case, our fuel source is being burned. And then an engine is a machine that converts fuel to usable mechanical energy. So what I mean by usable mechanical energy is, for example, if we all know, a car runs on gasoline, right? Were you to just, pour out some liquid gasoline, although it is technically an energy source, we can't use it to move our cars. It's just not how it works. But throughout this whole entire process, burning that and then moving parts and whatnot, it becomes usable mechanical energy, right? And then I'm sure a lot of you guys have heard this term before, but a V6 engine or V8 engine, right? I think most people would know like a V8 is stronger than a V6, right? But why is it called a V6 engine? Well, if you look at this image here, you can see it fans out in two directions, kind of like a V. One goes to one side, one goes to the other side. So that's where the V comes from. And then the 6 comes from the amount of cylinders. So in the image there, you can see at the bottom those 3 cylinders, and that's 3. And the other side mirrors that and has another 3 for a total of 6, right? So now you know where that comes from. Just kind of interesting, right? So if we look just a little bit more specifically at an engine, and I wouldn't expect you to memorize any of this sort of stuff, but it is kind of interesting and good to know. So parts of an internal combustion engine, right? First, you need fuel. Something needs to power the machine itself, right? So in most cases, gasoline is what we'd use to fuel it. And you also need, a variety of electrical sources. That's why your car has a battery, that sort of thing. But primarily with the system that we're looking at, fuel is the main source to power the machine. And then it's kind of split into 2 parts, or 2 big parts. So the engine head, which is composed of valves, camshaft, lifters, rockers, gaskets, and more. And then the engine body, which consisted of the piston, cylinders, spark plugs, crankshaft, the water pump, coolants, and the list goes on and on, right? But the key principle for you guys to understand is that if you take out one of these small parts that make up this big engine, right, then the whole thing doesn't work, okay? So you need all of these things, and they all need to be fine-tuned and operating well for the whole system to function. So that's how kind of fine-tuned this process is for it to even work and move our cars, okay? So how does an engine work, right? This is primarily described in terms of engine strokes, and each stroke refers to a different step in the process, right? Most engines use a 4-stroke process. The first stroke is called the intake stroke. So as I'm describing these, watch this GIF and try to, visually connect to the words that are on the screen and what I'm saying to you as well, right? So the intake valve moves to allow air fuel to enter into the chamber. Then the piston moves down, which increases the chamber volume. Okay? Now a lot of this will make more sense as we go throughout the process, so just hear me out on it, okay? Then stroke 2 is called compression. So both valves are closed in this step. The piston moves up, which decreases the chamber volume and increases the pressure of the chamber contents. So we've allowed in this gas, and gas will fill whatever volume it is presented with, right? So it started out as a very big volume, very expansive gas, right? And then as the piston moves up, the chamber volume is decreased, which compresses all of the gas, okay? And this increases the pressure. That gas wants to move. It wants to break free. It doesn't like being so, elbow to elbow with all of the other particles around it, right? So then this leads to the third step, which is called expansion. And some people like to call it combustion as well. So the spark plug ignites the chamber contents, which forces the piston down, and then all that gas expands, and it also creates this extra kinetic energy. So as I said, that gas was just waiting for something to release it and let it break free, right? So that's what that combustion does, that initial spark that sets it all aflame, and then it moves that piston back down, but it had so much more energy than was necessary to move it down. You have this excess energy that moves beyond this one cylinder and is able to continue the process for the rest of the car and create movement. And that's where the power comes from, right? But this is a closed cycle, right? So it can't just end there. You have to have a fourth step, which is called the exhaust stroke. So the exhaust valve will move to release the expanded contents. So unfortunately in this process, the gas is expanded beyond repair, right? It can't just continually be compressed and expanded, compressed and expanded. So we have to release it, okay? So that's what that final step does. And as you can see, releasing it pushes the cylinder back down, right? Which is good. Now, the big question for a lot of car enthusiasts and a lot of people in general is they really want to increase the power of their engine, and we've done this in a lot of ways. The first one, and perhaps the most simplest, is you just make the engine bigger, right? The more chambers you have, the more output you're gonna get, right? So this image is just purely hypothetical. Looks like it may be a V20 engine, right? That's way more power than anyone could ever need, right? But that's why a V8 is more powerful than a V6, because it has more chambers, more output, right? Another way you can do it is by increasing the amount of fuel burned. So if you have bigger intake valves or more powerful fuel to air ratios, then you're going to actually be burning more fuel in the same amount of time, right? And since fuel is that primary energy source that we are going to get that kinetic energy from, it makes sense that increasing that initial is going to increase the final, right? And then another way is by increasing the speed at which fuel is burned. We generally do this with better coordinated valves. So increasing that speed will also increase the power of the engine. So the faster we can burn the same amount of fuel, the more power is going to come out of that engine in the same amount of time. Again, that's pretty simple, right? And a lot of people will do this pretty simply too, by just adding a better lubricant to the engine and making all of these parts move faster, better, reducing the friction, right? And then the final one is by increasing the compression size within the cylinders. And you do this by just reducing the chamber size, or in some cases you can also just reduce the shape of the chamber. So by doing this, you're going to increase the amount of pressure on the same amount of gas or air fuel that's within the chamber. And the more pressure, the more force you're going to push that cylinder back down, and the more force is going to be generated for the rest of the functions, right? And now there's been more of a greater push for increased efficiency in engines as we kind of work towards a more sustainable world in the future. Transportation has a big part in that. So if we can make our engines more efficient, consume less fuel, have less emissions, that sort of thing, then we're going to be better off, right? One thing I will note though, at its very core, engines are just not efficient machines. Machines in general just aren't very efficient, but they're especially inefficient for moving people. So let me give you an example here. It's very hard to move an elephant, right? Because they're so big and heavy. It's a lot easier to move a single person. Well, your engine, to move you, has to move the car or the elephant, right? You're inside the car, So to move you relative to moving that car, it's very inefficient because you have to move the car to move you. So that just increases its inefficiency altogether. Ways that we've combated this, and this is a lot more recent developments, is by changing to a Miller or an Atkinson cycle. So a Miller cycle simply adds a sort of fifth stroke or 4.5 stroke to the normal cycle, in which the intake valves are open a little bit early and the exhaust valves are also open a little bit early, and it just increases the efficiency that way. The Atkinson cycle actually just reduces the amount of gas that actually leaves, so it opens the exhaust valve later. And then another way is by using less fuel and more air in the air-fuel mixture. This isn't as simple as just, use less fuel in there. The proportions still have to work to make this engine operate properly, but there is ways of doing it. Then another principle is this idea of cylinder deactivation and kind of valve timing as well. So if your car is going 55 miles per hour, for example, you probably need all of the cylinders to get that much power. But if you're going only 10 miles per hour, you can probably turn off a couple of those cylinders. You don't need them. You only need one, right? And then valve timing is kind of the same idea, right? If the valves are opening and closing at better times, then it's going to increase the efficiency. And then another way, and this is kind of by not working in the engine but working in the transmission, if you add gears to it, this allows for a higher variance in the cycle speeds that happen in your engine, right? So if you're going 55 miles per hour or 10 miles per hour, and you only have 2 gears, then all the speed within that are between those is on 1 gear. But if you have 6 gears, then all the speed within it can change a lot. And each gear allows for a different amount of air fuel inside of the engine or the amount of cycles per minute, right? And then other ways, primarily you see this in hybrid vehicles, are these ideas of stop-start and regenerative braking processes, which just kind of restores or reuses some of this wasted energy. Okay, so that was just a brief overview of the engine cycle, the internal combustion engine, and I hope you guys enjoyed it and learned a lot. Thank you.